several ways to deal with a big complex fraction, but the most straightforward way is to just kind of deal with it part at a time. So I'm going to deal with this bottom first, and I know how to add fractions, right? If this had been all by itself, it wouldn't have been so bad. All I need to do is get a common denominator. Looks like my common denominator is going to be xy. And so to make this an xy, I need to multiply by x. But I can't just multiply the bottom by x, I need to multiply the top by x. Why? Because it's a fancy form of 1. Remember when you did multiplication and you did your little flashcards and you were like relieved when you get to like the times 1, like 5 times 1 is 5 and 6 times 1 is 6, and it was like that was the easiest flashcard ever. And so now it's the same thing. We can multiply by this fancy form of 1, x over x is 1, and not change that. So every time you do these, you want to remember what you're doing, right? I'm not changing that. I'm just multiplying top and bottom by x, fancy form of 1, so that I can get the denominator to be xy, so I can get them to match. So here he needs a y. So now he gets multiplied by that fancy form of 1 as well. So, all right. Now they both have the same denominator, which means I can go ahead and add my numerators. So if I just bring this all down, I have this x just chilling, I have this minus y just chilling, and the bottom, I've got a common denominator of xy, and then I've got x squared plus y squared on top. I can add those fractions now. Cool. And so now I know that if I'm dividing fractions, I can multiply by the reciprocal. So I can say that this thing is y times, flip it over, xy times over, divided by x squared plus y squared. Cool. And that reason that works is because you're multiplying top and bottom by xy, another fancy form of 1, and then that guy cancels and this guy is brought up to the top. But flipping, we've gotten used to that, so that's cool. And so now you've just got this, and we keep simplifying this. So this is x minus, this is like a y over 1, so this is xy squared over x squared plus y squared. And now they want me to put these guys together, because this guy's as good as it's going to get. So to get these guys together, I need him to have a common denominator. So right now his denominator is 1. It'd be nice if it were x squared plus y squared. So I'm going to multiply him by x squared plus y squared over x squared plus y squared. So now 1 times x squared plus y squared and x squared plus y squared, they have the same base, same common denominator. And so on the top I'll have x times x squared plus y squared, and I can go ahead and subtract the xy squared. And so now, several ways to go from here. When I first did these, I just FOILed everything out and then refactored it. But now I've gotten a little bit smarter, and I look to see if I can factor out any common factors first. So I see an x in the top in both of these terms, so I'm going to factor it out, and I'll be left with x squared plus y squared minus y squared. And then the denominator's just chilling. And then the y squareds actually cancel. So I'll have x times x squared is x cubed. So I have x cubed over x squared plus y squared, and that is my answer. Woo!